In 2022, Australian scientists conducted a groundbreaking experiment that shook the entire scientific world. They sent a tiny particle backward through time. Yes, you heard that right. An actual physical particle was successfully sent into the past. And when scientists witnessed the results, everything changed, because it means time travel is not just a Hollywood fantasy. It is actually genuinely possible. But here's the biggest question that's been haunting physicists for decades. If time travel is truly possible, why can't we build a time machine? What's stopping us? Today, we're diving deep into the mind-bending science behind time travel and the shocking discoveries that could change everything we know about reality. Let's begin at the very beginning, the Big Bang. In those first violent moments, space expanded so rapidly that it left behind strange, thread-like structures called cosmic strings. These are unimaginably dense ripples in the fabric of space-time itself. And here's the terrifying part. A single cosmic string, just 1 centimeter long, would contain enough mass to outweigh entire mountain ranges. One tiny thread, and it could warp the sky around it. Physicist Richard Gott then asked a daring question: what happens if two cosmic strings pass each other at enormous speeds? When the mathematics came back, the answer was so shocking that scientists could barely believe it. The equations showed that matter traveling around those two strings could actually loop back through time, arriving before it ever left. To understand how, picture 2 points A and B. Normally, traveling between them takes time and distance. But cosmic strings warp space-time so severely that they create a shortcut, not just through space, but through time itself. Two different locations, two different moments in history, suddenly connected. Gott published his paper and the scientific world erupted. For the very first time, traveling to the past was shown to be mathematically valid. The only problem: we haven't been able to directly detect cosmic strings yet. We know they should exist from the physics of the early universe, but they remain frustratingly out of reach, possibly too distant, possibly too small to observe. Yet theoretically, the mechanism works. Now let's jump to another story, one that's equally mind-blowing. In 1994, in Mexico City, a physicist named Miguel Alcubierre was watching television. He was watching Star Trek, the iconic science fiction series featuring the starship USS Enterprise traveling at warp speed, faster than light. Now, Einstein told us nothing can travel faster than light. That's a hard limit of our universe. But Alcubierre saw something in that fictional concept that sparked a brilliant idea. Instead of moving the spaceship through space, what if we moved space itself around the ship? What if we compressed space in front and expanded it behind, creating a bubble that surfs through the cosmos like a wave? The ship inside wouldn't technically be moving at all, but it would arrive at its destination faster than light ever could. And that changes absolutely everything. Alcubierre's groundbreaking idea was simple yet revolutionary. What if, instead of moving an object through space, we moved space itself around it? Imagine 2 points in space, a starting position and a destination. Rather than propelling a ship from one to the other, we compress the space ahead of it and expand the space behind it. The ship itself stays perfectly still, while the fabric of space does all the work. This is the core concept behind the Alcubierre warp drive. Think of it like an airport moving walkway. You stand completely still, yet the floor carries you forward effortlessly. The Alcubierre drive works on exactly the same principle. The spaceship remains stationary, while space itself flows around it like a river. When Alcubierre published his paper in 1994, the scientific world was stunned, but immediately hit a massive wall. The energy requirements were absolutely staggering. We're not talking about the power output of a city or even an entire civilization. We're talking about energy exceeding everything produced by an entire galaxy. And not just any energy, a very exotic, deeply strange form known as negative energy. Now, negative energy sounds like pure science fiction. Everything we interact with daily, light, heat, electricity, carries positive energy. Negative energy, however, actually pushes space apart rather than pulling it together. It works against gravity itself. But here's where things get truly mind-blowing. Negative energy is real. In 1948, Dutch physicist Hendrik Casimir predicted that placing two metal plates extremely close together in a near-perfect vacuum would generate a mysterious attractive force between them, produced by negative energy. For decades, scientists dismissed this as theoretical curiosity. Then in 1997, physicist Steve Lamoureux experimentally confirmed it in a laboratory setting. The plates moved exactly as predicted. Negative energy exists. The catch? The amounts produced are almost incomprehensibly tiny, nowhere near the quantities needed to power a warp drive. But the principle is proven, and that changes everything. Now, let's look at something even more extraordinary that's happening right now. CERN, the European Organization for Nuclear Research, operates the world's largest physics laboratory buried deep beneath the Swiss countryside. Its crown jewel is the Large Hadron Collider, a colossal circular tunnel stretching 27 kilometers underground. Inside, scientists accelerate subatomic particles to nearly the speed of light. And at those extreme velocities, something remarkable happens. Time itself begins to slow down for those particles. While 10 seconds pass for us, far less time passes for the particle. These particles are, in the most technically precise sense of the word, traveling into the future. This isn't speculation. This is observed, measured, and confirmed every single day inside that facility. Time dilation is not a theory, it is a documented reality. Calculations show these particles experience roughly 0.02 seconds less time than everything around them. Small? Absolutely. But the implications are staggering. Genuine time travel proven in a laboratory happening right now beneath our feet. Time travel isn't just science fiction anymore. In 2022, researchers at Queensland University in Australia conducted a groundbreaking experiment. They built a simulation, and inside that simulation, they sent a particle backward through time. The universe didn't break. It simply adjusted itself so that everything remained perfectly consistent. That sounds mind-bending, but here's the stunning part. Scientists actually pulled it off. Then in 2023, Google's quantum computing team achieved something eerily similar. Using one of the most powerful quantum processors ever built, they demonstrated time reversal behavior at the quantum scale. And what started as microseconds became seconds, then minutes. The implications are staggering. Here's something that will blow your mind. Every single one of you is already a time traveler. No, seriously. The moment you start moving, time behaves differently for you than for someone standing still. Whether you're in a car, on a plane, or simply walking down the street, time is literally passing at a different rate for your body. The difference is too tiny to feel, but it is absolutely real and measurable. GPS satellites prove this every single day. They move so fast that time actually runs differently for them compared to us on the ground. Engineers must calculate and correct for this time distortion constantly. So every time you open your Maps app and navigate somewhere, you are directly benefiting from Einstein's theory of relativity, the very foundation of time travel science. Now the real question, can we ever build an actual time machine? Going forward in time is surprisingly straightforward. Build a spacecraft capable of approaching the speed of light, travel for a while, return to Earth, and you will have leaped into the future. The math works. The physics allows it. But going backward, that's where things get wildly complicated. Scientists have identified three theoretical pathways: cosmic strings, the Alcubierre drive, and quantum-level time reversal. All three are mathematically valid. None are currently buildable. But a century ago, nobody imagined we'd hold supercomputers in our pockets either. Stephen Hawking once devised a brilliant test for time travel. He threw a party and only sent out the invitations afterward. His logic: if time travelers from the future existed, they'd have received the invitation and shown up. Nobody came. Hawking saw this as evidence against time travel. But there are actually three possible explanations. Either time travel is truly impossible, or future travelers deliberately chose not to interfere with the past, Or, and this is the theory gaining serious traction among physicists, time machines can only transport people back to the moment the machine was first switched on. You cannot travel to a time before the machine existed. That's why no visitors arrived at Hawking's party. The machine hadn't been invented yet. The evidence is mounting. Time travel isn't just theoretically possible. We're already doing it at the smallest scales imaginable. The only question left is how far we can push it.